Hello everyone, here is a question based on electronic configuration. Find the atomic number of an element having 3 unpaired electrons and belongs to transition series with the +2 oxidation state. We know that in a neutral element, number of protons must be equal to the number of electrons. Here the atomic numbers of neutral elements are given, and therefore if the atomic number is 22, it means titanium, 23 means vanadium, 24 means chromium, and 25 means manganese. Now in the neutral element we will have 22 electrons here, 23 electrons here, 24 electrons here, and 25 electrons here. However, when it goes to +2 oxidation state, then it is titanium 2 plus. Now we will have only 20 electrons, isn't it? So for the neutral titanium, the electronic configuration will be argon, that has 18 electrons, and then 4s2 3d2. We would be removing 2 electrons from the 4s2 orbital because the principal quantum number is equal to 4 here. This is the outer shell. So we would have 2 unpaired electrons in the case of titanium 2 plus. But how about vanadium? For vanadium neutral, the electronic configuration will be argon and then 4s2 and then 3d3. So if we remove 2 electrons to get the +2 oxidation state, then we will definitely have 3 unpaired electrons, and therefore vanadium is the correct answer. For chromium neutral, the electronic configuration will be argon and then 4s1 3d5. We shouldn't write it as 4s2 3d4 because that is wrong. This will have higher amount of exchange energy. Half filled and completely filled d orbitals are more stable. Therefore writing it this way is correct. Now to get the +2 oxidation state, if we are removing 2 electrons, then for chromium 2 plus, the electronic configuration will be argon and then 3d4. So we have 4 unpaired electrons here, and therefore that is not the correct answer. And for manganese neutral, the electronic configuration will be argon and then 4s2 and then 3d5. So here if we remove 2 electrons, we will have 5 unpaired electrons. Therefore that is also not the correct answer. 23 electrons, option 2 is the correct answer here.